Welcome to the session. I am Dr. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, I am going to discuss on nanomaterials and its synthesis type, one of the synthesis method like chemical reduction method, and what are the applications of nanomaterials. Today, we are going to focus on all these preparation of nanomaterials by chemical reduction method and its applications we are going to see more in detail. First, nanomaterials. What are nanomaterials? Coming to this point, the nano means, it is a Greek word. The nano means dwarf, and materials means dwarf materials, means small materials. A nanometer is 1 billionth or of a meter. So, in a meter, 1 billionth part is called a nano, which means that nanoscale is incredibly very small. So, the prefix nano means 1 billionth or 10 to the power of minus 9. Therefore, 1 nanometer is 1 billionth of a meter. Nanoparticles generally exist in between 1 to 100 nanometer scale. So, it is difficult to imagine just how small it is. So, here are some examples we can going to see here. Generally, the science which deals with the nanomaterials is called the nanoscience, and the technology which uses the nanomaterials and nanosciences is called the nanotechnology. And here, this is the nanoscale. So, the scale which we use to measure these nanomaterials, it is called the nanoscale. So, it exists from 10 to the minus 1 to 10 to the power of 8. So, 10 to the power of 8 is the size of the tennis ball. And then here the bacteria, virus, antibodies, glucose, water comes under this category. So the 1 to 10 to the power, this is the nanoscale. So very small substances, like very 1 billionth of a meter. So 1 billionth of a meter is the nanoscale. So these they exist in different forms, again 2D, 1D, 3D. Like based on the dimensions of the materials, these nanomaterials will be existed like 1D materials, 2D and 0D and 3D. So, these materials range from 1 to 100 nanometers. Coming to the synthesis of nanomaterials, there are two types of material synthesis using with this nanomaterials. This one is top-down approach, one is top-down approach, and another one is bottom-up approach. There are two types of synthesis in nanomaterials. Here, this is bottom-up approach. This is top-down approach. So, the synthesis of these nanomaterials will be like atoms, ions and molecules. They all together form, they undergo a chemical reaction under certain conditions, results in the formation of nanoparticles. Whereas this top-down approach, the bulk precursors or the bulk substrates, they crushed by the mechanical action. It may be through the ball mill or the mechanical force. They are crushed into very small nanoparticles. So, this is from larger molecules to smaller molecules, from bottom to up approach, small molecules to nanomolecules. In detail, the top-down approach is, the material is reduced from bulk size to nano scale. So, the size of the material means the size of the substrate or the precursor will be very high, means macro or big, which is under the pressure or the mechanical strength, it was converted into the nano size particles. So, it is macro to micro approach. Example, ball milling method or nanolithography is used to convert these macromolecules into micromolecules or the bulk precursors into nanoparticles. Here, if we see here the ball mill, it is a metal balls are used inside a cylinder where the nanoparticles or the bulk precursor compound is added. So on crushing, on moving in a circular motion, the particles are crushed or pulverized into very small fine sized powder form. So this here we can see on the process moves on, these particles are converted into very small nano scale particles. So this is the method is used generally in ball milling method. Coming to the another method called nanolithography. Here these nanoparticles are mixed with these nanoparticles are under optical lens. These are used for printing and like coating on the surfaces, like these nanoparticles are got inserted, these optical lens are mixed, and then it was used for printing technology. So this is top-down approach, means the bulk compounds are converted into fragments, then the nanostructures are formed. So up to here, this is top-down. If it is bottom-up, the small atoms or ions or molecules undergoes reaction and form clusters, then gives the nanostructural compounds. In bottom-up approach, matter in atomic or molecular level, so the ionic forms or molecular forms present in the atomic state gets assembled, means they get combined to give clusters. These clusters which grow to reach nano size, means it is from small to big, means micro to macro. We can see the atoms, they combine together and give the clusters. These clusters which grow into nanostructures. So under this bottom approach, the chemical vapor deposition and physical vapor deposition soil gel methods are generally these are the methods for the synthesis of nanomaterials. But the approach which uses with these all methods uses is bottom up approach, means small molecules are combined to form clusters, and these clusters joined together and grow into the nanostructures. So one of the method in bottom up approach is chemical vapor deposition. So this is CVD. This process is generally termed as CVD. It is a chemical process used to produce high purity, high performance solid materials. In this process, the substrate is exposed to one or more volatile precursor, means easily evaporatable precursors which react and decompose on the substrate surface, means which substrate surface which we are going to use to produce the desired deposit. So this is the substrate. We are going to deposit the nanoscale or nano layer on this substrate. So again high volatile precursor are used. Here these are the gases. The gas will go through this. This is the substrate which we are going to deposit the nanoscale on this substrate. So what happens in this reaction chamber, the gas which the reactant gas go and expose it to volatile precursors, so they react and give the deposition, and the waste gases are eluted. This whole process will happen under the presence of heat. So it is a heating chamber where this reaction will take place, and the deposits of the nanomaterials will be on the substrate. These gaseous precursors react to form a solid coating on a heated substrate. Here the substrate is heated continuously. This causes the solid coating of nanomaterials on the substrate. Next method in the bottom up approach is physical vapor deposition. The material is heated above its melting point to generate the vapors, which are then deposited on the substrate or target surface. It involves the generation of vapor either via evaporation or by sputtering or laser ablation or using an ion beam or electron beam. So using these two beams like ion beam or electron beam, this was allowed to get evaporated. It may be by any process like sputtering or evaporation or laser ablation. So by this process, if we see here, it was getting evaporated, and then it goes and deposit on the substrate layer. So the substrate or target surface is get deposited with the nanomaterials by the use of this highly volatile or melting means the material is heated up to above its melting point. So it causes the vapor generation. so which go and deposit on the target surface. Next method in bottom-up approach is sol gel process. The sol gel process involves the evolution of inorganic networks or colloids called sol gel through the formation of a colloidal suspension called sol and gelation of the salt to form a network in a continuous liquid phase gel. So here the chemical precursor was used. Here the metal alkoxide with solvent was used. Here in the presence of water, it reacts with the water. This metal alkoxide with the solvent reacts with the water. It undergoes hydrolysis. Result in the formation of sol, means a colloidal suspension will form. This is sol. So again, the formed sol is converted into gel by the removal of the water molecule. So this is called the condensation process. Here the water molecule was removed. Then it results in the formation of a gel or network of these nanomaterials. Again, this is the gel. So again, this gel will be undergoes calcination process and drying process where excess water and solvent molecules carried from the first step to, so this is the first, from this solvent molecules will carry to here. So in this step, all the solvent molecules, water molecules present left from this step, all are removed and converted into a fine powder, or depends upon the calcinate process, the process which we used for calcination, the network or the structure of the nanoparticle will be decided. So here this is the nanoparticle formation. So this is the steps involved in the sol gel process. It is one of the bottom-up approach method used for the synthesis of these nanoparticles. And another method is for preparation of nanomaterials is chemical reduction method. It is also one of the example of bottom-up approach. So the chemical reduction takes place. So the name itself indicates the chemical reduction is going to take place in the process of synthesis of nanomaterials. So hence the name is chemical reduction method. The chemical reduction method consists of generally 3 stages. First, the reduction of metallic salts by the reducing agents and the stabilization of ionic complexes and controlling the size of the nanoparticles by using the capping agents. Many different types of metallic nanoparticles can be synthesized using this chemical reduction method. So in all the processes, the 3 steps are involved. One is the reduction of metallic salts which we are using as a precursors by using the reducing agent, and the second one is the stabilizer. So thus formed complexes has to be stabilized. These ionic complexes formed should be stabilized, and third step is the controlling of the size by using the capping agents. So in this method, first metal precursor solution such as a metal solution, it may be a silver chloride, copper chloride, or any metal salt solution, first is treated with the reducing agent, and appropriating stabilizing agents are added, because here the first step is reducing agent. We are going to reduce the agent or the metal by using reducing agent. Then the ionic complex formed with the metal has to be stabilized. So we are adding the stabilizing agent. This is the second step. Once this ion complex formation is happened, then we have to decide the size of the particle. So we have to add this. To regulate this, we have to add the capping agent. So after further treatment and drying, nanoparticles of metal are formed. Example, the synthesis of silver nanoparticles by this method. So here the metal salt solution. So this is silver salt. So here the silver salt is added, then reducing agent is added externally, because the silver salt solution when heated, the reducing agent reduces the silver ions. So thus formed silver ions have to be stabilized. Then the capping agent is added here. Then the metallic, this NP means nanoparticles. The metallic nanoparticles are formed like this. This is the way involved in the chemical reduction method synthesis of nanoparticles. And this is the silver nitrate solution is taken as a metal precursor, then and hydrogen hydrate as a reducing agent. Here we have to add reducing agent. So that is reducing agent means these are silver, black ions or silver ions. Reducing agent is hydrogen hydrate. This is AgNO3 solution. Means it contains silver ions. These two are added, then these green and black ions are going to react. Then then the capping agent is added. From here, stabilizer and capping agents. Then it results in the formation of silver nanos. Silver NPs means silver nanoparticles. So the sodium dodecyl sulfate SDS is used as a stabilizing agent. This reaction has to be carried out at room temperature, means no need to heat. Like these methods, some methods in bottom-up approach which we are seeing has to be heated. Even in Sol-Gel process, the solution has to be heated, and physical vapor deposition and chemical vapor deposition. In these methods, the substrate has to be heated. Here, in this chemical reduction method, the reduction takes place, but there is no need to heat the solution. So, the transparent colorless solution converted into the characteristic pale yellow. We can see here, this pale yellow color was formed. So, then pale and pale red yellow color. The occurrence of this color indicates the formation of silver nanoparticles. So, the silver nanoparticles are generally purified by the process called centrifugation. This centrifugation is nothing but the material or the solution is allowed to rotate in a specified rotations per minute. So, after the centrifugation, due to the gravity or centrifugal force, the solid particles or the heavyweight particles will get deposited on the bottom of the tubes. So, to remove excess silver, the silver colloids were washed at least 3 times with a deionized water under the stream of nitrogen. So, the thus obtained silver nanoparticles, so which is a dried powder of nano size, means it will be in 100 nanometer range, 1 to 100 nanometer range, only that thus formed size only we call it as nano size, and can be obtained by freeze drying. The particle size of nanoparticles will be around 15 to 48 nanometers. So, this is the silver nanoparticles. So, after freeze drying, they have 15 to 48 nanometers of their size. Another method of this chemical reduction method for the preparation of copper nanoparticles. Generally, these copper nanoparticles can be prepared by this chemical reduction method, in which copper salt is the metal salt, which is going to reduced by some reducing agent such as sodium borohydride, hydrogen, ascorbic acid, and ascorbic acid, hydrogen and ascorbic acid is used as a capping agents. So, the chemical reduction method can be used for the preparation of different metal nanoparticles by the suitable reducing and capping agents. So, here this is the copper precursor, means copper metal salt is going to reduce by adding sodium borohydride or hydrogen and ascorbic acid as a capping agent, which results in the formation of. So, after this, after adding the reducing, here we added copper precursor and reducing agent, here mixing. Then the copper precursor was formed here. Then it was allowed to react by using this suitable capping agent. Then after 10 minutes, the copper nanoparticles are obtained here. Then again centrifugation, separating or washing and then drying. Finally, the resultant is copper NPs, means copper nanoparticles are obtained from this procedure. This is called the chemical reduction method. By using this method, we are going to prepare the copper nanoparticles. Next is the preparation of gold nanoparticles by chemical reduction method. So the gold particles are synthesized by this chemical reduction method. Here we are using the metal salt, which is gold chloride, and this is with undeionized water. So the first step is reduction. So the gold ions in the gold chloride solution are reduced to zero valent gold atoms. We are going to reduce the plus 4 here are of gold plus 3 ions to zero valent gold atoms by using reducing agents like sodium citrate, sodium borohydrate or hydrogen. So these are the reducing agents which we are using generally to reduce the gold atoms from plus 3 state to zero valent state. So these ions will reduce the gold atoms like the sodium citrate, either sodium citrate or sodium borohydrate or hydrogen employ and they acts as a reducing agent. Coming to the next step, which is called a stabilization. So to prevent agglomeration, means this agglomeration is nothing but like it decomposes its chemical nature, like they form a coagulates in the reaction. It won't it which is a resultant of agglomeration. A stabilizing agent has to be added to prevent this agglomeration, or such as capping molecule or polymers has to be added for the stabilization. So this ensures that the nanogold particles remain dispersed at nanoscale in the reaction. Next is the size control. The size of the nanoparticles can be controlled by addition of the concentration of the precursor and the reaction conditions. Next, the thus formed gold particles are ranging from 9 to 11 nanometers are obtained from this reaction. So the first thing is here the gold precursor is going to heated. It is when next step is reducing agent. The reducing agent may be sodium citrate, sodium citrate or sodium borohydrate or hydrogen. So this acts as a reducing agent. Then here Au plus 3 will be converted into Au0. Again, this is on mixing and heating. This red color gold nanoparticles are formed. Here, the solution of gold solution has to be heated and it has to be like boiling has to be done. Means reflex. The bubbles has to come out. So then the salt like metal which is gold present in this solution becomes soluble in water. So above the boiling temperature or above when it was got reflexed, the solution of present in this will have the soluble gold ions. Then addition of this trisodium citrate or sodium borohydrate or hydrogen which acts as a reducing agent, they convert the soluble Au plus 3 ions into Au0 ions. So then the continuous heating and stirring for about 10 minutes. This time the plus 3 ions are converted into Au0. The neutral gold atoms aggregate. First they collide and they form aggregates into some seed-like crystals. The crystals continue to grow and eventually form this gold nanoparticles, which is this red color solution is the gold nanoparticle solution. These gold nanoparticles generally have unique physiochemical properties. So they are adversely used in the application fields of like biological applications and making them as a promising candidate for the applications in biological applications or medical fields. So this is the gold solution. When it undergoes some solvents or reducing agent, then gold solution or nano gold colloids will be formed. See, this is Au plus 3 ions. The colloid formed will be then converted into Au0 with colloids called these nano gold colloids or nanoparticles. Here, these gold nanoparticles will be nanospheres, nanoshells, nanorods, and nanoclusters, nanocays, and nanostars. So, depends upon the formation of these particles. There are different types in gold nanoparticles. Depends upon the application also. This synthesis will happen. Coming to the applications of nanomaterials. Because of their dominant and unique physiochemical properties, they have adverse applications in different fields. Starting from the medical to the environment, they have very good properties to withstand all the conditions. So they are used widely in all the fields for its applications. Then coming to the biomedical, so these nanoparticles are used in biomedical and healthcare and even in construction materials and electronics and energy storage and environmental remediation, food packaging, processing and agriculture industry and even as a renewable energy sources. So this biomedical and healthcare, they are used in targeting the specific site to treat that area. So coming to the construction materials, these nanomaterials play a vital role in the construction materials. Then electronics and energy storage, they are used in the photovoltaic cells, even the preparation of a very small cells in chip preparation, even in the electronic semiconductors. These nanoparticles are used in the preparation or manufacturing of the semiconductors. Coming to the environmental remediation, these to remove the pollutants from the air and water, these nanoparticles are used. Thus, they are applicable in environmental remediation. And coming to the food packaging and agricultural industry, these nanoparticles play a very crucial role. Coming to the renewable energy, as to improve the light absorbency in the photovoltaic cells of the solar panels, these nanoparticles are incorporated in order to absorb more light from the sunlight. So they have a wide range of applications in all the fields. Coming to the biomedical, so especially gold nanoparticles are used in drug delivery system, even in imaging and photoacoustic imaging and photothermal therapy. So these nanoparticles are used in all the types of treatments. The next step is catalysis. Due to the uses of these nanoparticles as a catalyst, they improve the surface area of the substrate and they causes the reaction even more rapid and in a good way. The good yield will be there because of using this nanoparticle compounds or nanoparticles in catalysis reactions. The next thing is in the application of electronic field. They enhance the performance of the electronic circuits or devices, example conductive inks, transparent conductive films. They enhance the performance of the devices because of the uses of nanoparticles or incorporation of these nanoparticles in these devices causes the better or enhanced performance. Another one is the environmental remediation. These nanoparticles remove the pollutants from water and air. So these nanoparticles are applicable in the are cleaning these are very eco-friendly and they are used as to remove the pollutants from water and air. Coming to the material sense, they improve the material properties such as strength, conductivity and this mechanical strength of the compounds or the materials can be improved by the nanoparticle materials. The optics. The nanomaterials exhibit some unique optical properties which are useful for imaging processes. So this causes the application of these unique properties of these nanoparticles causes the application in different fields. This is all about the nanoparticles and the synthesis of nanoparticles by chemical reduction method. So the metal which may be silver or copper or gold, this involves the reducing agent to prepare or to convert the metal ion into the reduced form. So it undergoes reduction, then the thus formed ionic complexes has to be stabilized by using stabilizing agents. Thus formed agents has to be undergo the capping reaction with the capping agents to have the particular size. Then that thus formed complexes has to be dried, undergo drying process or centrifugation or washing to get the pure nanoparticles. Thus formed nanoparticles are applicable in the different fields depends upon their usage and applicability and properties. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.